All right, class. So we're going to be looking at how we can write equations of parallel and perpendicular lines. But before we go into our examples and just a little bit of a review, we got to understand what we need to do in order to do parallel and perpendicular lines. Two lines are parallel if they have the exact same slope. Okay, so we have to remember that when they ask us to write an equation that is parallel, we have to make sure the slopes are exactly the same. Two lines are perpendicular if the slopes of the two equations are opposite reciprocals. So when we write an equation that is perpendicular, we got to make sure the slopes are opposite reciprocals. Now, I may say something different like different flip, but it's the same thing. Opposite and different, for us, what it means is for the signs. The signs have to be opposites of each other. That means one positive, one negative. Reciprocal or flip, that means they're flip versions of each other. One will, like you would see numbers where the fractions are flipped over, like it might be 5 over 4 and then the other one be 4 over 5. That's what they mean by reciprocal. Okay, now the steps that we're going to use in order to write an equation is that we're going to get the original slope, which I will say is the OG. Okay, so we're going to get the original slope, then we got to convert that slope to be either parallel, which is the same, or perpendicular, which is your different flip. Okay, then we're going to use the new slope and the order pair that they provided us with to find the b. That's all for b. And then we're going to write out the new equation. Okay? But before we do the full 4 steps, let's look at how we can find our original slope. I feel like this is important because they're going to give it to us in 2 formats. One of the formats is what we call standard form. So with standard form, you will see it as written as ax plus by equals c. The other format is called slope-intercept. Slope-intercept form is going to be your y equals mx plus b. Now let's break that down. Slope-intercept form and standard form. If we look at slope-intercept form, now we've seen this before, but y equals mx plus b, slope is given because in that format, slope is going to be your m, and m will be beside the x. But now if you look at standard form, there's no m in this format. So that means we actually have to do a little bit more work in order for us to find what the m will be. Okay? But now let's look at some examples and see how easy slope-intercept form is and what we have to do to standard form in order to get the slope that we need in order to write the equation. So like in the first one, we have y equals negative 5 over 2x minus 5. Now that is slope-intercept form, where the m is slope and it is beside our x. So that means it's going to be beside the x every time in that format. So if we look at that one like in this problem here, we have negative 5 over 2 right beside the x. So that means my m, which is my slope, is negative 5 over 2. Same thing in the next one. So if we look at this equation where we have y equals negative x plus 3, when we look at that problem, right beside the x is a negative. But there is a number there. It's an imaginary 1. So that means the m in this one will be negative 1. Now in the last one for slope-intercept form, you're looking at y equals negative 4x minus 1. Right, again, in that same format, we're looking right beside the x because the m is beside the x. So if we look right beside it, we got a negative 4, so that means my slope is negative 4. Okay? Now, in slope-intercept form, given. That's easy. Now, in standard form, like I said before, there's no m present. So that means we got to go find it. And the way that we're going to find it, we're going to move up and look at this one where we have 2x minus y equals 1. There's no m in this, so we got to make adjustments or make changes in order to get it. Now, these are the changes that we're going to make. The first thing we're going to do is we're going to take the number that is in front of the x, we're going to put it at the top of a fraction. And that's a positive 2. Okay? So the first thing we did, we moved the number in front of the x. We're going to put it at the top of the fraction. Now there is a number beside the y. We're going to take that number and we're going to move it down to the bottom of the fraction. Okay, so that means that was a -1. So we put that at the bottom of the fraction. That's the second thing we did. The last thing we're going to do in order to get slope for us, this is the third thing, we're going to insert a negative. And we're going to insert a negative as the last step for every one of them, no matter what. So we're going to put a negative out front. So when we look at that, we have a negative out front with a +2 over -1. Now the last thing you do in every situation with a fraction is make sure it's simplified. So in order to simplify a fraction, if you have Desmos, you can go to your Desmos and you can type it in exactly what you have. We have a negative first, okay, and then we have a 2, then we have our fraction bar, so we hit divide, and then we have a -1 at the bottom. And when it simplified it for us, it gave us a +2 as our slope for this one. All right, so let's do that again. So in this example, we have x plus 2y is equal to -8. So we're going to take whatever's in front of the x, which is no number, so it's going to be a 1 here. We're going to put that at the top of the fraction. We're going to take the number that's in front of the y, you're going to move it down and put it at the bottom of the fraction, which is a +2, and then we're going to insert that negative. So what we have is a -1 over +2. If we simplify that in Desmos, so we have a -1 over 2, which is +2. We get a decimal, and then if we click the button right here to change it back for us, so that means our slope is just -1/2. All right, one more time, and then we'll be able to get into the actual questions of writing the equation. So in this example, we have 4x minus 3y is equal to 9. So again, we're going to take the number that's in front of the x, we're going to put that at the top. If it was a negative number, I would put a -4, okay? So you take the number and the sign with it. And then I'm going to take this -3, and we're going to put it at the bottom of the fraction. And then we're going to insert that negative. Okay, so what we see is a -4. Let me back up. That should be a 3. And I put my negative back, so that's going to be -4 over -3. Two negatives when you divide become positive. 3 can't go into 4 evenly, so we have a +4 over 3 as the m for that one. So when we look at it all and finding our original slope, slope-intercept form is the easiest. Standard form, we got to do a little bit of changing, but we can still find it without doing a lot of work. It's not much work. So this is how we're going to find our slopes in the two formats that they can give us in the problems. So now let's look at some examples of how to fully complete all 4 steps of how to write our equations of parallel and perpendicular lines. All right, so let's look at the first example. The first example says write the equation of the line that is parallel. That is important. So we're looking for it to be parallel to y equals 3x minus 2, and it passes through the point at -1, -2. So the first thing we got to find is we got to find our OG. We need our OG slope. After we find our OG slope, we need to get our new slope. Once we get our new slope, we're going to use the point in the new slope in order to start writing our equation. But let's go ahead and complete step 1. Step 1 says get our OG. Now, in the format that they gave us y equals mx plus b. So because they gave us y equals mx plus b format, which is standard slope-intercept form, That means slope is given. So that means the slope for me this time is going to be a positive 3. And because it is parallel, that means it is the same. So that means I'm going to use 3 again. All right. Now we're going to use the point that they provided me with, which is a -1 and -2. We're going to label it X and Y. Okay. Once you label it X and Y, the next thing you can do is we're going to take that X and Y and the new slope, we're going to plug it into y equals mx plus b, because that's what we have to use in order to write the equation, which has to be in slope-intercept form for us to compare. So if we do that, we're going to write it in y equals mx plus b format. We're going to be filling in the numbers that matches the letters that we have. Like we have a y, because the y that they said that we had, which is here, is also here, and it should be -2. So underneath y, I'm going to put -2. We know what our new m is, which is slope, which is a positive 3. So underneath that, I'm going to put positive 3. I'm going to put a parenthesis because the m and the x are side by side. That means multiplication. And if I put a parenthesis beside a number, that means I'm going to multiply it. Okay? And the x that they gave me was a -1 plus b. Okay? So now that we have that set up, we're going to go to Desmos and we're going to do that multiplication. We're going to do 3 times -1. That's going to give me -3. I bring my plus b down and my -2. Now my goal is to get b by itself. So that means I'm going to do the opposite by adding 3 on both sides. Double 3's cancel out. Then I can go back to Desmos and type in that operation that I have, which is -2 plus 3. And that's going to give me 1. So the b for my new equation will be 1. And then I'm going to use the new slope that I got to write my equation. So that means I'm going to have y equals 3x, and the 1 I got was a positive, so it's a +1. So the equation that I have that is parallel to y equals 3x minus 2, and it passes through the point -1, -2, is y equals 3x plus 1. All right, so now we're going to move to the next example where it says that we're going to write the equation that is parallel, there's that word parallel again, to 2x minus y equals 3, and it passes through the point -1, 2. So first thing we're going to look for is our OG slope. That's the original. Second thing we got to get is our new slope. Once we get those two things, we can plug into y equals mx plus b and get our equation. All right, so the OG this time is in standard form. Standard form, we got to do a little bit more work. So we got to remember that we're going to take whatever's beside the x, we're going to put it at the top. And whatever's at that's beside the y, I'm going to put it at the bottom. That's a -1. And then I'm going to throw my other negative in front. So what we got is -2 over -1. If we simplify that, that's just going to be 2. Okay? And because it is parallel, it's going to be the same. So that means I'm going to be using 2 as my new slope. The point they gave me was -1 and 2. And I'm going to label it x and y. So that way I can plug into y equals mx plus b. So under y, I'm going to put 2. Under m, I'm going to put a 2 because that's my new slope. Parenthesis, x, which is -1, plus b. So then I can go to my Desmos. I can do my multiplication, which is going to be 2 times -1. It's going to give me -2 plus b. Now bring everything else down. Now I got to get b by itself by doing the opposite of what's the number beside b, which is -2. So I'm going to add 2 to both sides. The double 2's, which one is negative, one is positive, they cancel each other out. Then I got these 2 positive 2's here. That's 2 plus 2, which makes 4. So that is my new b. Okay? So if I put my equation together, it will be y equals 2x plus 4. And that equation will be parallel to the one that we have, which is in standard form, which is 2x minus y equals 3. Okay? Now, when you're doing parallel, you just got to remember it's the same slope. There's no changing in it, okay? So now we're going to look at an equation for our next example that is considered to be perpendicular. All right, let's look at our third example. In the third example, it says write the equation of a line that is perpendicular to the equation y equals 2x minus 3 that passes through the point at -2, +3. Now, we have to remember that with perpendicular, it's going to be a different flip, okay? So it's not going to be the exact same slope. We got to remember different flip. So it's still the same. We're going to, first thing we got to get is our OG. And then from our OG, we got to get our new slope. Okay, so because it is in slope-intercept form, slope is given. The slope in this case is going to be +2. But because we're doing perpendicular, remember different flips, so that means the difference is that if that's positive, that other one got to be negative. And the flip is me flipping the number over. If you notice that the 2 is by itself, so what they say is technically it's at the top of a fraction. When I flip it over, that means the 2 will be at the bottom of the fraction. And then I can't leave the top blank, so I have to put a 1 there. Okay, so the new slope will be -1/2. Now I can use my point, which is at -2 and 3. And then from there, I can label it as x and y. Okay, and then I can plug that into y equals mx plus b. With me plugging that into y equals mx plus b, I'm basically filling in what I know. I'm filling in the y, which is 3. I know that. I'm going to fill in the m now that I know it is -1/2 because that is my new slope. And then a parenthesis. Then I'm going to fill in the x, which is -2 plus b. Now we go to Desmos. And when we go to Desmos, we'll type in exactly what we have for the multiplication, which is -1/2 times, so we got to press over and hit times, -2. That's going to give me 1. So I bring the 1 down and I'm going to put my plus b. Bring my 3 down. Now I got to get b by itself, so for me to get b by itself, I'm going to do the opposite of the +1, which is subtract 1 on both sides. Double ones cancel out. 3 minus 1 is going to be 2, so my new b is 2. So now I can write my equation, which will be y equals, now I'm going to use my new slope, which is -1/2, x plus 2. So this equation will be perpendicular to the one that we have there, knowing that it is perpendicular because we did the different flip. You see, you got a 2, and then we got a -1/2, and then it intersect at the, or crosses through the point at -2, 3 using what we have after we solve. Now in our last example, in this last example, it says write the equation of the line that is perpendicular to 2x minus 3y equal -6. And it passes through the point -2, 3. Same thing. Perpendicular, different flip, but we need our OG. So let's get our OG first. So in this one, because it is in standard form, we got to do a little changing. So this number goes to the top. This -3 will go to the bottom. And then I put in my extra negative. So, but we have 2 negatives, so that becomes positive. So the OG slope will be 2/3. Now my new slope got to be different. If it's a positive 2/3, once everything was simplified, that means my new slope will be a negative. And we started out with 2/3, and if I do my flip, that becomes 3/2. Okay, so now we use the point. The point they gave me was -2, 3. That's going to be my x. This is going to be my y. So with that, I can plug in y equals mx plus b. Matching up my letter and my number. Y is 3, so underneath y I put 3. My m was -3/2. That's my new one. Parentheses, my x is -2 plus b. Okay, then I go to my Desmos. In Desmos, I'm going to start me a new line. That's going to be negative 3 over 2 times negative 2. With that, we'll get positive 3. So we're going to bring down 3 plus b in the other 3. Now, with that, we got to move or get b by itself. So we're going to subtract 3 on both sides. These 3's here cancel each other out. 3 minus 3 is 0. That's equal to b. So that means I can now write my equation. It's going to be y equals, my new slope was negative 3 over 2, x plus 0, or you will see it as just y equals negative 3 over 2x. All right, so now we completed all our examples of how to write equations dealing with parallel and perpendicular lines. We saw how we can change standard form into just getting the slope that we need. Okay, if you have any questions, don't hesitate to ask.